你想成为一个名副其实的白领吗？你想拥有一份令人羡慕的高薪工作吗
？Involved from R1 over to R2. Obviously it goes through different types of interfaces as well with these devices. But the cable as it structures across has a logical division within it that is called a virtual circuit. So each of these divisions will be called virtual circuits. Now there's two types of virtual circuits involved in frame relay. The first is a switched virtual circuit. And what this means, it's pretty much just a temporary virtual circuit, or on demand, if you will. Whenever we have traffic that needs to travel across this connection from R1 to R2, a virtual circuit will be built on demand, and it will only be up as long as we are passing data. So there's no idle state here. As soon as the data is done passing through this switch virtual circuit, it's torn down. Now, the other side of that, the other type that we have, is called a permanent virtual circuit, or a PVC. The way you build this is it's built manually from R1 through this frame relay network over to R2. And that permanent build means that we are going to have an idle state. In other words, whether there's data on the line or there's not data on this virtual circuit, it's still going to be up, which is a very important characteristic because if you recall, part of the demand for frame relay was the fact that it needed to handle bursty traffic. Now, the switched VCs don't take that long to bring up, but obviously they do take longer than a permanent VC because it's already up. And whenever you're dealing with bursty traffic, you don't want the traffic to burst and then have to deal with the setup time on an SVC, come across, and then the teardown time. So I think that the permanent virtual circuits are better for most instances. Let me give you an analogy to help you remember the difference between the two types. First, we're going to start with the permanent virtual circuit. I have two mountains here and I need to cross. And what I will do is build a permanent structure, a bridge, across the two. Now, it doesn't matter whether people are going across this bridge at a particular time or not, that bridge will still be standing and ready for that to happen. That's the permanent virtual circuit. Now, with the switch virtual circuit, you're going to have to use your sci-fi mind for me for a little while. Movies like Star Wars and other sci-fi movies will have a tunnel and little landing pads throughout that tunnel. Now, if you envision hallways coming off of these landing pads, obviously, that can lead into this junction, if you will, or intersection, as soon as somebody steps on this platform, a bridge extends across to the other side so that you can walk across. As soon as that person is on the other side safely, that bridge goes back to where it was, and then there's nothing within the middle. This is similar to what an SVC operation will be. And then another one can be created here. Make your passage across, it'll go back into where it came from, and then another can go as well. And this is an SVC type world. Before we leave the terminology section, I want to clear up one possible point of confusion. These are frame relay switches that operate here. Now, you're used to switches operating at the data link layer, which is layer 2 of the OSI model. But when you walk up to one of these, if you ever get to see one, they're actually going to be routers set up for frame relay switching. Now, you're used to routers operating at the network layer, or layer 3 of the OSI model. Don't get thrown off. Once you type in the command frame relay switching, then at that point this router is going to operate at the layer 2 for frame relay interfaces. Encapsulation has been mentioned in our terminology discussion already, but now we're going to take a more detailed look of exactly what happens when we're talking about encapsulation on a frame relay network. Here we have our network depiction again, complete with our DTE devices, these being the interface devices, and then also our DCE devices, the frame relay switches that exist within the frame relay cloud. Alright, now let's look at encapsulation. N1 is going to send out a data unit. And this data unit, as mentioned earlier, has nothing that tells you it's going to exist on a frame relay network. In fact, N1 isn't aware of that. It's not until it gets to router 1 that these changes take place. Here we're going to see representations of the OSI model, the different layers, this being the physical, the data link, and the network layer, so the first 3 layers, so that we can have a point of discussion. When this data unit comes into the router here, it is going to be decapsulated all the way up to layer 3. Then layer 3 is going to pass across within the router, and then we're going to encapsulate again. When we go for this encapsulation here, this is where the frame relay header is going to be placed around the data unit that used to exist as this original frame. So this frame exists right here, and now we have a new header, a new FCS, which is the frame check sequence, which means it's going to run a computation against the information that's in this protocol unit, and it's going to say, okay, I came up with a specific number, whatever it is. Let's say 1639. Now, when it arrives at the distant end, you need to do that same calculation and come up with the same number. If you don't, then this packet or data unit has been tampered with. Alright, so we see here that this is where frame relay encapsulation actually takes place on the way down the protocol stack at the interface device. And it's going to exist all the way through. Here's the frame relay switch. It receives that new frame. It goes up to layer 2, transmits across, encapsulates again, sends over the wire, does the same thing at the next frame relay switch, across at layer 2, over the wire, until it gets to router number 2. It's going to decapsulate going up. In other words, it's going to strip the frame relay information here. And when this data unit is encapsulated again at this point, this is where it is going to exist as it did here when it took off from N1 and be transmitted into N2, which again will be unaware completely that this came through a frame relay network. What you see here is a generic representation of a frame relay frame. It is not exactly what is going to be used on the wire, but was simplified for the sake of our discussion. Now we're going to find out exactly the types of encapsulation that are available within the Cisco router for frame relay. And we're going to find that out when we use this command. At the configuration mode, once you're inside a specific serial interface, so this is config IF, you're going to type in the command encapsulation space frame relay, and at this point hit the question mark. And what you're going to get is two choices. One, simply return or hit enter, and the other is IETF, which is a standardization board that came up with a standard encapsulation that can be used between multiple vendors. In other words, Cisco and some other vendor, this is when you would use IETF. If it was simply Cisco to Cisco, then you could use the enter because that results in the default Cisco encapsulation. Now let me explain the difference between the two types of encapsulation, and you're going to see them here. The top is the Cisco encapsulation, and it is just like our generic representation in that it has flags, and it has the data, has the FCS, and a flag. This is the portion that is specific to Cisco. You're going to have an address field, and that is a 2-byte field, and you're also going to have a packet type field that's a 2-byte field that is used to identify the upper layer protocols that are being encapsulated by this frame. Alright, now the other choice we had was IETF, and this is built on RFC 1490 as a standard. And again, we're going to have the flag, the data, the FCS, and the flag that we had in the generic representation. And then we're going to have the address field that is exactly the same as we see up here in the Cisco area. The rest of this specific fields for the IETF frame are going to be the control field, a pad if needed up to 1 byte. So 1 byte in the control field, 1 byte in the pad, and then what's known as a network layer protocol identifier. Simply put, it does the same function as this packet type, it just does it in a different way, and it does it in a way that can be standardized between multiple vendors, where this packet type is specific to Cisco. Let's demonstrate this in the router. Alright, as you can see, I'm at the privilege mode. I'm going to type in configure from terminal, and at that point, as I had mentioned, I need to be in an interface. I'm in router 1, and I'm going to go into interface serial 0. Once you're in there, you can type in your encapsulation command, complete with shortcuts, so I don't have to type out the whole word encapsulation. And then I'm going to type in frame relay, frame dash relay, remember that or it won't let you complete your command, then the question mark. And here's where we have our choices. Again, the IETF, as we had mentioned, it uses RFC 1490, and then also it's been RFC 2427 has been revised as well. Or you can simply hit enter, and that's going to default for the Cisco type of encapsulation, and that's what we're going to do here.